Hello, my name is Daniel Hassler, and I will be demonstrating today the AI ML components of our application, GobbleUp. So, to approach the AI portion of our application, we wanted to make the most out of the food data in our database collected by our scraper. So, our goal here is to group food items together in a meaningful way so that we can create diverse, semantically rich clusters of food items. These clusters would allow us to generate diverse meal plans with more refined search criteria, like give me the seafood options or give me the vegan options. The intuition of this approach stems from the idea that items that are semantically similar hold similar nutritional information. For example, chicken and pork should be in the same cluster, whereas chicken and wine are more unlikely to be in a cluster. So for our approach, we use the BERTopic model, which is an unsupervised clustering algorithm that extends beyond simple clustering by extracting meaningful topics from these groups. So it goes through a few different steps here. One of the first step is deriving the SBERT embeddings from the raw text, which is a very rich, semantically meaningful text embedding algorithm here. And then the second step is running a dimensionality reduction technique called UMAP. And then the third step is running a HDB scan clustering algorithm on those reduced embeddings. And then a class-based TF-IDF approach for topic creation, which identifies the most representative words for each cluster. So using this model in practice, we are training a BERTopic model on our food data for every day in our database, given the food offerings for that day. So here I've already trained a model off scene here. This is a model from 4/14/2024. So here I have all the clusters in their representative topic form. So cluster 0 has these words, and cluster 4 has these words. And here's a visualization of all of that. So what we see here is that all these food items are grouped semantically in semantically meaningful clusters, which is very good for our meal planning generation. So as you can see in topic 0, we have salad, dressing, Caesar, Italian. So I would classify this as a salad cluster. And topic 1 here is muffin, cookie, toppings, chocolate. So I would say this is like a sweets or a dessert cluster. So as you can see, it does a very good job at grouping similar food items together, which is very nice for our application. So as you notice here, these topics are labeled as topic 20, topic 21, or like topic 18. And we can't really get that much information out of that, right? Like we want to be able to have a summarizing theme for each of these clusters. So we use the power of large language models to label these sort of topic vectors. So what we do is we pass in these topic representations into a Q&A prompt into our llama model, and then try to classify it. So here's the first topic, I believe, and we have a couple of multiple choice questions. So we have a very directional output. And as you can see, I mean, it got the answer wrong, but for a lot of the categories, it does get it right. And then here's an example of how we're using that in practice. So now I will show how this works in our application. So obviously there's a few more steps between training the model and running inference. So here is an example of how we're generating our meal plan. And it's important to note here that we're actually generating our meal plan based on the user's preferences, the location, the serving time, and some other nutritional views that are necessary for the calculation. So I know Kirk has probably already showed this for our front end stuff, but as you can see, the generated meal plan it comes back with is all we think are pretty good options and are nutritionally rich for a lot of the cases. Obviously, there are some hiccups here and there, as we do say in each plan that we want to generate one drink, but sometimes the drink that it returns with is like vinaigrette, which is obviously not a drink. So there is some limitations to this approach, but we are working on fixing those. And the The fact that we can generate meal plans based on this clustering scheme and LLM guided labeling is pretty impressive, and it does come back with good results. And that concludes my demo.